So being able to create a function if you've been given a domain is kind of the epitome of understanding really the heart of finding the domain symbolically. So you might want to practice the first section a little bit more before you try to follow along with this. But if we know our domain restrictions well, then we can create a function for that specific domain. It also is important to note that there could be a lot of different answers for these, but we want to be able to justify our reasoning for each function that we choose. So it says write a function with a domain of negative infinity to positive infinity. So really a function with all real numbers. This has a ton of different examples you could pick. So I might pick something like y equals 2x minus 5. That's a linear function. We know that a linear function would have a domain of all real numbers. Keeps going on up and up and up. We could have picked a quadratic, so I could have said something like x squared plus 3. That would have no restrictions. We could pick something like 5 to the x. Again, no restrictions, it's exponential. As long as whatever you chose doesn't have a restriction, then you're fine. But our restrictions, if we remember, came from a rational function or a radical function with an even index. And those are the two main restrictions that we are looking at. There are other restrictions in different types of functions, but so far this is what we're focused on. So let's write a function with a domain of 2 to infinity. If I wrote that out, let's kind of remind ourselves of this number line. 2 to infinity would be closed circle at 2 and shaded to the right. So let's think about what functions have we seen that created some type of restriction like this. And that was a radical function. So a radical function, just remember, if I moved it to the right 2 and went off like that, that would have a domain of 2 to infinity. The way that we did that was take that square root and move it right 2. Now if I have a domain with negative infinity to negative 6 union negative 6 to infinity, we see that this excluded value is negative 6. So x cannot be 6 or negative 6. That happened when we had a rational function. So a rational function can be anything on top that we want, but x plus 6 is in the denominator. Remember, it's plus because, think about if we had solved that, x plus 6 cannot be 0 because it's in the denominator, so x cannot be negative 6 if we kind of work backwards a little bit. So here's the denominator. X plus 6 is in the denominator. It doesn't really matter what you choose to put in the numerator. So I could put a 1, I could put a 5x, I could put anything I want, really, so that it would have a restricted value of negative 6 at this point. But for right now, there's a potential example. And then number 4, write a function with a domain of negative infinity to negative 1 to 3, 3 to infinity. So if we look at these excluded values, negative 1's excluded, 3's excluded. So x cannot equal negative 1, and x cannot equal positive 3. Again, that gives us something like a rational function. So let's look at that rational. In the denominator, x cannot equal negative 1. That means we would have had a factor of x plus 1, and then x cannot equal 3, so I'd have x minus 3 in the denominator. The numerator, again, could be whatever value we want, but we do have to have something up there. I'll put a negative 7x squared. Whatever we want up there, as long as it's not a square root, because the square root would add another restriction to it. All right, number 5. Write a function with a domain of negative 4 to infinity. This looks very similar to number 2. So we have from negative 4 with a closed circle all the way to infinity shaded to the right. we need a radical function, so something like a square root, and it does have to have an even index, so maybe I put a 4th root to make it a little bit different. You could do a 6th root, you could do an 8th root, but as long as you don't do an odd index. And inside the radical has to be greater than or equal to 0, so that means that the -4 is what was our problem. So if I had solved that, remember x plus 4 is greater than or equal to 0. If we moved that 4 over, we got our -4. So we're just kind of working backwards. The last two here, we'll see some combination things. So we write a function with a domain of -4 to 3 and 3 to infinity. Look at what changed. We had a function that was -4 to infinity, but now we've excluded 3. So on a number line, we had something like this, but now when I get to 3, it's an open circle. So that open circle, if you remember, that we've been talking about, came from having something in the denominator. So I'm going to put x minus 3 in the denominator. But the radical negative with the -4 was something like square root x plus 4. If that's in the numerator, then it could be equal to this thing. If it was in the denominator, it could not equal 0, so it would have an open circle here. So let's look at this last one. The difference here is now we have 7 to infinity, but 7's not included. Looks very similar to this -4 to infinity, except for this was a bracket and this is a parenthesis. So the change is that I don't get to have just the radical. It's going to have to be something where it could not equal it as well. So let's put in that radical, x minus 7. If it's in the denominator, it takes away the equal to part, so it's just strictly greater than. And then the numerator can be whatever we want. Let's say it's 2x squared plus 5x minus 11. That didn't have any restrictions in the numerator, but the denominator did.